Understanding space weather and its impact. Space weather refers to the environmental conditions in space, including solar winds, solar flares, and coronal mass ejections, CMEs, which can interact with Earth's magnetic field. These solar phenomena can significantly affect satellite systems, power grids, and communication technologies. Solar flares and their disruptive effects. Solar flares are intense bursts of radiation from the sun. When directed at Earth, they can disrupt radio communications, especially in the high-frequency bands. This can cause temporary blackouts in communication systems used by airlines, military, and maritime industries. Coronal mass ejections and power grids. CMEs are massive eruptions of charged particles from the sun that can collide with Earth's magnetosphere. When these charged particles interact with the Earth's magnetic field, they can induce electric currents in power lines, potentially damaging transformers and leading to power grid failures. These events can cause widespread blackouts. Satellite damage from space weather. Satellites are particularly vulnerable to space weather. The radiation from solar flares and CMEs can damage satellite electronics, impairing their functionality. High-energy particles can also degrade satellite materials and disrupt GPS signals, which are essential for navigation and communication. Impact on GPS systems and navigation. Space weather can cause ionospheric disturbances that affect GPS signals. The increased ionization of the Earth's atmosphere during solar events can lead to signal delays or errors, impacting the accuracy of GPS systems used in transportation, military operations, and daily navigation. Disruption of communication systems. The ionosphere, which helps transmit radio waves, can be severely affected by space weather. Solar storms can cause signal absorption, leading to loss of communication with satellites, especially in remote regions like the poles. This disruption can affect emergency services, weather forecasting, and commercial operations. Radiation hazards to astronauts and spacecraft. Astronauts and spacecraft operating outside Earth's protective atmosphere are at risk from space weather, particularly during intense solar storms. High levels of radiation from solar flares and CMEs can pose serious health risks to astronauts, potentially damaging sensitive spacecraft components and threatening mission success. Effects on aviation and high-frequency communications. Increased solar activity can affect aviation, especially at high latitudes. Solar storms can cause increased radiation exposure to passengers and crew. High-frequency communications, essential for planes flying over remote areas, can also be disrupted, making it difficult for pilots to maintain contact with ground control. Long-term technological vulnerabilities. In the long term, the increasing reliance on technology, such as the expansion of 5G networks and the growth of satellite constellations, makes Earth more vulnerable to space weather. A major solar storm could disrupt a range of systems, from internet services to banking operations, highlighting the need for greater resilience against space weather. Monitoring space weather for preparedness. To mitigate the effects of space weather, space agencies and organizations closely monitor solar activity. Early warning systems are essential for anticipating solar flares and CMEs, allowing for preventive measures, such as shutting down satellite systems or reorienting spacecraft, to minimize damage and protect critical infrastructure.